This is Professor Urbis White. Today we will learn how to deal with ellipses. It's one of the conic sections in an intermediate algebra level. So let's get started. Okay, we're not going to go too deep, but we are going to learn how these equations work. An ellipse equation looks like this. You're going to have a plus, that's what's important, between those square terms. And you're going to have an a square and b square. It's easy to actually remember this. Let me just show it to you. Let's say I have my xy coordinates, and here is my center of the ellipse, and an ellipse looks like this. It doesn't have to be this way. This is the horizontal one. So this center is going to have the coordinates h, comma, k. How am I going to remember? This h is with the x, so it's going to be this distance, h. And k is with the y, so it's going to be this distance, k. Alright? So that's centered in there. So there's a plus, and there's a 1 on the other side. So that's easy. What is this a and b? Now, when you look under x, this a is under x, so that is this. This is how wide it is, okay? So this one is a, one of it, and this one is a, and so together it's 2a. Got it? Alright. This one is now b. This is under the y, so that means half of it is b, the other half of it is b. Again, together it's 2b. Does it make sense? Alright, so ellipse centered at HK with these dimensions has this equation. So let's look at this. What would this one look like? This ellipse would be centered at 1, 2. Why? Because this 1 is after this negative, this 2 is after this negative. It's squared. It looks like it's fitting this equation. Now, what does this mean? So it's going to be 1, 2 around here. 1, 1, 2. And now what's going to happen? This is 2, okay? So that means 1, 2 this way, 1, 2 that way. So it's going to be that fat. And this is 3. That means 1, 2, 3 this way, 1, 2, 3 that way. So look. So this ellipse is kind of like elongated. Do you see that? This is my ellipse. Actually, when you think about it, when these lengths are the same, when these lengths are the same, that becomes the diameter of the circle, okay? So ellipse is a general formula, but the circle is actually an ellipse when these two dimensions are the same. Okay, so that's that. Let's look at another equation. What would this one look like? This one is x plus 1. What does that mean? X plus 1 means x minus minus 1, right? You do a little trick in there. So that means, because the formula has a negative in it, so it's going to be centered at -1, comma. This one doesn't have a plus at 1. So one way to remember, so when you see inside the parentheses a plus, your coordinate is going to have minus. When you see inside the parentheses minus, your coordinate is going to have plus. That's how it works out. You either think of it like that, plus, so that's going to be minus, minus, that's going to be plus. Or you can actually try to match the dimensions. 3 means, if it is like that, so it's going to be 3 and 3. Here's the center. It's that way, 3 and 3. And 2 is that way, 2 and 2, 2 and 2. So this ellipse is like that, and where is this center? At -1, 1. Okay, let's look at that one. Where is this centered? It's going to be centered at 2, and there's a plus, so it's going to be -1. So it's centered at 2, -1. How fat is it that way? 2 fat. So here's my center. Let's assume it's at 2 and -1. So it's going to be 2 this way, 1, 2, and 2 that way, 1, 2. And this one is 3, 1, 2, 3, 1, 2, 3. So it's going to look like that. All right? Okay. So let's look at some other cases. Well, can I have some ugly numbers in there? Okay. Yes, you can. So let's try to make this work. You know that I'm supposed to have a 1 on the other side and the squares and a plus. Okay, this 9 is on the other side. So I need to have a 1. So what do? Divide everything by 9. All right? So when you do that, you get x plus 0.5 squared. You divide everything by 9, so you already had a 4. 4 times 9, that's 36. Plus y minus 1 3/4. And I divide that by 9, so you have a 9 here, equals 1. Oh, look at that. I can actually write this as x plus 0.5 squared. And 36 is 6 squared plus y minus 1 3/4 is 1.75 squared over. You don't have to change fractions to decimals. I just did it so that you can see it. Now this looks like an ellipse. Now, where is it centered? It is centered at, this is plus at negative 0.5 and 1.75. All right. How fat is it that way? It's going to be 6 fat. How fat is it that way? 3 fat. So you're going to have 6. Here's the center. And another 6. Here's the center. And you're going to have 3 here. And then 3 here. So it's going to look some like that. And the center is going to be at negative 0.5 and 1.75. Again, don't let the ugly numbers get you. This may be getting you, so let's look at it. Now, I need to do a couple of things. I have a 0 on the other side. This doesn't look anything like my ellipse equation. Remember, my ellipse equation is supposed to be x minus h squared over a squared plus y minus k squared over b squared equals 1. It doesn't look like it. So, let's do some work in here. So, I have x squared and x. So, let's get these together. X squared plus 8x. So, I got these two guys out of the way. This one I have 2y squared minus 4y. But I don't have the numbers in front of y squared. So, let's take out that 2 and rewrite this. Y squared minus 2y. Does it make sense? So I dealt with these two. Equals 0. And I'm supposed to make this a perfect square. What am I missing? So how do you do completing the squares? You take the 8, you divide it by 2, you get 4. Then you take that 4 and square it, you have 16. So I'm missing a 16. So I need to put a 16 here. I cannot just put a 16 in there. I need to put 16 on the right hand side. All right. Now what do I have? I have x squared plus 8x plus 16. Now let's do the same thing with this one. 2. I have y squared minus 2y. Now let's not look at this. Y squared minus 2y. So I look at this term. Divide by 2, that's negative 1. Square it, so that's 1. What's that mean? I need a 1 here. Okay? But when I put a 1, you actually did not put 1. You put 2. So because 2 times 1 is 2. So I cannot just put 2 in here because I feel like it. I need to put a 2 on the other side as well. Okay, look what I have now. X plus 4, so this is completed the square form, plus 2, y minus 1 squared equals 16 plus 2, 18. Now, let's look at this. What can I do? I need to divide everything by 18 because I cannot have this 18 in there. So let's do that. All right. Let's see what I have now. I have x plus 4 squared over square root of 18 squared, because I need to have a square at the bottom, plus, now 2 divided by 18, that cancels out 1 and 9, so I have this, y minus 1 squared over 9, but 9 is 3 squared, equals, guess what, 1. Now it looks like an ellipse. Where is it centered? Centered is plus 4, so it's going to be at negative 4 and 1. How fat is it? 18. So let's look at this a little bit. What is 18? 18 is 2 times 9. So which is that 9 comes out is 3 rad 2. So it's more than 3. So this is going to be, if this is the center, 3 rad 2, 3 rad 2 away from the center. And that is more than 3, right? And then the 3 is going to be this way, a little smaller. So this is 3, and this is 3. So it's going to be fat this way. Does it make sense? And where is, excuse me, where's the center? The center is at negative 4, 1. So I did show you how to complete the squares in an ellipse. So let's kind of put it together. If somebody describes it to you, how does this look like? So let's look at that. They say, what's the equation of a horizontal ellipse? Horizontally means fat this way, horizontally. Horizontal ellipse. It's going to look something like that. Vertical ellipse. It's going to look like that. All right, so I'm looking for a horizontal ellipse. Centered at 1, 2. So that means I'm going to have x minus 1 squared, y minus 2 squared. That's kind of given. And the length of this major axis is 8 units. Major axis, that means major axis, the fat part, that's called major axis. And in this case, this is the major axis. All right? So the length of my major axis is 8. Half of it is 4. So what is that going to look like? So the half of it is 4, so it's going to be 4 squared. And the length of its minor axis is 4. That means half of it is 2, so it's going to be 2 squared. Does it make sense? So if you want to draw this, hopefully I'll draw it right. 1 and then 2. It's going to be 4 that way. 1, 2, 3, 4. 1, 2, 3, 4. So it's going to go that far. And this one is 2. There's no negative in here. It's my pen. So it's going to be 2 up, 1, 2, and 2 down, 1, 2. Does it make sense? And let's put it together. So it's going to look like, so let's make sure that this is the case. Horizontally it's centered at 1, 2. Yes, it's at 1, 2. Length of its major axis, length is 4 and 4. That's 8 units. Good. Length of its minor axis, which is like that, 4 units, 2 and 2. Now I'm done. All right, so you can go back and forth. You can look at an equation and then draw it and figure out where your center is and your major and minor axes are, how fat your ellipse is, if it's vertical or horizontal, or they can give you a description and you can actually go back to the equation if you know the equation. And if they don't give you the equation in the form that you want, in the standard ellipse form, you do complete in the square to put it in that form and you're done.